Okay, so here is where we are in looking at pollution movement in surface water, and these couple of videos are going to talk about sediment transport. So first, a little bit of an intro, sort of why we care and what are the sources, where does it come from. So first, we've talked quite a bit about things that actually stick to solids like sediment. We've got negatively charged clays here that attract cations. And we've also talked about organic matter that can attract some of the anions like sulfates and phosphates. And then we actually even just talked about plastics that can absorb things like with high KOWs like PCBs and DDTs. Soils also absorb both of these things, but all of these particles can absorb these sorts of chemicals, pollutants. So then why does that matter? That matters because particles and soils don't always stay put. They tend to move around. You can see this picture. This is sediment runoff, or sediment in spring runoff going into Lake Champlain in 2011. And it's part of our actually part of our big phosphorus problem. I'll have a graph to show you guys that in just a minute. In fact, right now. So this is showing you total phosphorus on the y-axis here in micrograms phosphorus per liter versus total suspended sediments in runoff from rivers, tributaries going, in this case in the Winooski River, going into Lake Champlain. And you can see it's a really straight, nice correlation between the amount of sediment and the amount of phosphorus. So there's a lot of phosphorus that's attached to sediments going into the lake. So just one reason why we care about how sediments get moved around and how fast and where they settle, all those sorts of things. So sediment load, what is it? It can be any number of things. It can be, most frequently we're talking about sediment, things that weather from rocks, soils, and the density of that we generally tend to assume is about 2.6 grams per centimeter cubed. But we can also be talking about organic material from plants, bacteria, algae, fish, and this has a density slightly greater than water. The density of water being, again, 1 gram per centimeter cubed. So it floats, by and large. Leaves float, little pieces of organic matter float. And organic carbon is really, really great at absorbing pollutants. And we'll talk about that a little bit later, again, in the course when we're talking about soils and below ground movement of pollution. So where does sediment load come from? What are the sources? A lot of it is erosion. So this is a river in Oregon, the Smith River, and its parent material is granite. And you can see there's not a whole lot in the river in this case. The granite does not weather very well, or it doesn't. Rivers moving through granite bedrocks don't tend to have a high sediment load because they don't get eroded very easily. And this is the Colorado River, which moves through a lot of sedimentary rocks, and you can see even between tributaries you can have a lot of variation. So you've got one river coming here without a sediment load. In fact, this is coming from the bottom of a dam, so this is where you're removing the sediment load, and then this is an incoming undammed river. You can see it has an incredibly high sediment load, and that's pretty common for undammed rivers in the west and southwest because the bedrock there tends to be sedimentary, things like sandstone that get eroded pretty easily. So we also have erosion of soils, and this can have to do with things like land use and management. So a forested landscape probably won't have quite as much of sediment running off of that landscape as you will in an agricultural setting, particularly if you don't have anything planted on that land at the time. So that's where management can come in. And we saw this in actually Irene and some of the other big flooding events. Areas that had cover crops had much less erosion than areas that did not have cover crops. And we had huge gullies running through unplanted fields without cover crops or anything growing on them, whereas next door fields that did have cover crops fared much better. They kept a lot more of their soil in place. Okay, so I'm going to stop the little intro there, and the next video we'll talk about transport of sediment.